Today we are going to talk about AWS EKS blueprints. I will try to explain what was the reason behind creating them and how you can improve your infrastructure by using them. As you can see in the agenda, we are starting with infrastructure as code approach benefits. We will discuss the tools you can use for it. Then, trying to understand how much time we need to set up an EKS cluster and what we can automate. And finally, I will show you how to use EKS blueprints in a demo. In the end, we will have some time for your questions. I hope many of you are aware of the infrastructure as code approach, but let's go through the benefits it offers once again. I put some of them in a random order so you can prioritize those that matters most to you. This approach boosts productivity through automation, adds consistency in configuration, minimizes the risk of human error, and adds accountability. To some extent, it can improve the documentation for your infrastructure, and hence security is worth being on the top of the list. If it's not enough, just imagine how much free time you can have while waiting for your infrastructure building from the code. If you've been in the cloud engineering domain for some time, you are aware of many different tools you can use for infrastructure as code. If we are talking about AWS only, we have at least CloudFormation and AWS CDK. If you are using multiple cloud providers, you might be aware of Terraform or Palomi. If you are an old-school engineer, you might think of Ansible, which also can be used for creating infrastructure. But I decided to take it out of the scope because of the other reason. But what to choose if you are not biased yet? Let's see what Google Trends says about these tools. HashiCorp's Terraform is the winner for sure. Lucky me, I decided to use Terraform on my projects a while ago, and no need to switch so far. Of course, it's the reason why we are going to talk about the Terraform AWS EKS blueprints. However, there are other options available. AWS CDK EKS blueprints as an example. How long it would take to spin up the AWS EKS cluster? When I looked for references, I found an AWS blog post which claims that it roughly takes 9 minutes to spin up a cluster. It's an amazing result, but is it ready to use? Not really, and I will explain why. Please try to recall what additional controllers and services are present in your normal, ready-to-work cluster. I guess there are many. Cluster Autoscaler or Carpenter, Node Termination Handler, AWS Load Balancer Controller, Ingress Engine X, Certbot, External DNS, Prometheus, Alert Manager, Grafana, and many others depending on your use case. Each of them requires additional configuration and integration with other components. My bet is you need several hours just to make your cluster ready for real work, and could take much longer if you are following some outdated how-to or were unlucky to have version incompatibility between components. So, what is the traditional workflow if we need something of the before-mentioned installed to make our cluster functional? Firstly, we are installing EKS using EKS-ctl command line tool. Then, using Helm, we are installing Helm charts. But don't forget to create all the IAM roles, bind service accounts, open ports and security groups. Hopefully, you don't need self-managed node groups for your workload, because creation of them will take an additional time. Did I forget anything important? Of course I did. You need to document the whole process and pray that you will not need to repeat it again over your other regions or accounts. So, what are EKS blueprints? Terraform EKS blueprints especially. It's open source GitHub repository with a set of integrated modules, which makes it easier to create fully bootstrapped EKS clusters with the operational software you need. Using it, you can solve all the problems I raised before. What else to add? Is it actively developed by the community? Many projects contribute to adding support for their software as add-ons. You don't need to worry about versions, upgrades, and changes in Terraform providers. It will be done by a friendly community. Are you ready to see how it works? I'm going to show you how easy it is to create a fully operational EKS cluster using Terraform AWS EKS blueprints. I cut off some background work to save you time, but I will show you all the milestones and how much time it took for each skipped step. I created for this demo small basic Terraform project. It contains of some predefined locals. I'm defining region, VPC CIDR, and so on. Also, it uses external models, actually Terraform AWS EKS blueprints with specific version, to create an EKS cluster with managed node group. We need this small managed node group to have a space to deploy our basic components, such as CoreDNS, kubeproxy, and at least cluster autoscaler or Carpenter. Also, I'm using submodel of main project to define which add-ons I'd like to install. For beginning, I enabled only basic AWS EKS add-ons such as VPC CNI, CoreDNS, kubeproxy, and EBS CSI driver. I'm going to measure how long it would take to deploy the basic EKS cluster, and because of that, I have all other components commented out so far. At the end of file, you can see one more module. It's a default one to create VPC. It's well-known best practice to not use default VPC for your workload. I have defined single net gateway. It's pretty much enough for our test. Also, I have public and private subnets in each of our 3 availability zones. And finally, we have some tags applied to our subnets. It's a requirement for AWS load balancer controller and cluster autoscaler. That's pretty much it. So let's deploy our cluster. Terraform init will download all source codes of all modules and install and configure all providers. It takes some time, so I'm going to pause the video and back when it's done. It usually takes only a few minutes and we are ready to run our Terraform apply. Normally, we are using Terraform plan to see what the changes will be applied to the infrastructure, what resource created, what changed, and so on. But in our case, it's enough to see output, what Terraform apply provides to us. Anyway, we will have one more confirmation before changes will be applied to the infrastructure. And I'm going to use time just to check how long it would take. All looking good, and we see what resources will be created for us. There are a lot of resources. You can see IAM roles, policies, security groups, managed groups, Helm charts, and many other things that must be created to have your cluster running. Let's go. Yes. Once again, it takes some time, so I'm going to put it on pause and back when it's done. Here we go. Everything ready. You can see that it took 25 minutes, but it's not only EKS cluster created. As you can see, there are 67 resources has been created. It's VPC, Net Gateway, security groups, subnets, EKS cluster itself, managed node groups, all the IAM roles and policies, and also EKS add-ons. I'm trying to find how long it took to create only EKS cluster, and you can see it's 8 minutes 23 seconds. It's roughly 9 minutes, as Amazon promised it would take for create EKS cluster. Let's copy paste the command from the output to configure our kubeconfig. Because of I have locally multiple AWS accounts configured, I will extend the command with additional parameter profile to specify exactly the profile I'm using for this demo. Next step is switch our kubectl to use the just created context. We can do it by running following command. Let's see if our cluster working. You can see 2 nodes created inside our managed node group. We can see all the add-ons we just installed. For test purposes, I prepared simple deployment. There are nothing special. I'm using only the post container to create a load. I put in requests 1 CPU and it does nothing. Let's create it. Well, good. Our deployment created. Let's see if we have any pods. There are nothing. Did I use specific namespace for deployment? No, so it should be deployed to our default namespace. I don't see it anywhere. Okay, let's check the deployment. We can see it's where it expected to be, but we have 0 out of 0 pods ready. So yes, we have 0 desired replicas. And I totally forgot about that. So let's scale our deployment to 5 pods. And let's check again. Finally, we can see that our pods created, but only 2 of them ready and running. So what is the reason? Let's check the status. And here's the go. We have insufficient CPU because in our request I specified 1 CPU for pod and we have only 2 worker nodes. It's not enough to run all our workload. Let's back to our Terraform module and see how we can fix that. For scaling purposes, we usually using Carpenter or Cluster Autoscaler. So all I need is to enable it and run Terraform apply again. I'm going to measure time again. Let's see what resources it's going to create and how long it would take. Okay, so again, everything we need for our cluster autoscaler. We have policy, we have Helm chart with all predefined settings. We have some custom settings we added via the cluster autoscaler Helm config. We have IRSA role, and we have service account. In overall 5 resources. Let's create them. I will pause the video and back when it's done. This time it was quite fast, it took only 2 minutes, but it's expectable because we were installed only cluster autoscaler and corresponding resources. Let's see if it works. No, and looks I know what is wrong. Cluster autoscaler itself, it also deployment, which requires some resources, but we already out of resources. So let's scale to the 0 our inflate deployment and see if our cluster autoscaler is ready. Good, it's in a ready state, so let's scale back to 5 again and see if any reaction. It was quick, so we see that cluster autoscaler found all the resources that are waiting for workers and decided to create 3 more nodes in our cluster. Let's wait while they be ready. 2 of them ready. Good. We have all 3 new nodes in ready state, and we can see that our deployment is fully functional. So, what if we'd like to add anything else? Let's enable metric server, AWS load balancer controller, cert manager, and all we need is just run Terraform apply once again. This time, Terraform is going to add 15 more resources. Again, it's policies, roles, everything you need to make your Helm chart working. Everything you usually creating by running specific AWS CLI commands, following the how-to or instruction. Pausing video here and back to you when it's done. And 2 minutes later, we have installed our AWS load balancer controller, metrics server, and cert manager. Let's check status of all components. We can see everything running, all good. Our cluster is fully functional and can scale when more workload comes. Because I'm not going to use this cluster anymore, it was created only for this demo, I'm going to destroy it. And because everything has been created with Terraform, all resources will be removed, and there are no any leftovers in our infrastructure. It took additional 13 minutes to remove everything and return my account to the initial state. That's all I wanted to show you. Let's move to the questions. Please ask your questions in the comments, and I'll be happy to answer all of them. Let me drop some of the open questions I have. It would be great to discuss them with somebody one day. Thank you for watching this video till the end. Hope you learned something interesting. Feel free to contact me directly if you have any questions you'd like to discuss.